Hello everyone, in our switching system final presentation, for our finals project we've decided to do an arithmetic logic unit design. So an arithmetic logic unit is a circuit that does arithmetic and logical operations. So for our finals we've decided to do an 8-bit design. So before we begin our presentation, let us just quickly go over the design. Let us begin our presentation by turning our circuit on. Our switch is now on. So in our design, our ALU can receive two numbers which are up to 8 bits each. So we can put any numbers up to 8 bit. So in input A, I'm gonna put, for example, 15, which is a 4-bit number. And for input B, let's put 13, which is also a 4-bit number. Okay, so now on this two set of numbers, I'm gonna do some arithmetic and logical operations. Let us begin with the logical ones first. So according to a table, the first operation is 0, 0, 0. If you type that thing in the operation selector, it will do an AND operation. And as you can see, it is 0, 0, 0 in the operation selector, and that's the output, AND output. And if you want to store this in the memory, it's stored in the memory. From there, let us do the OR operation, which is 0, 0, 1, 0, 0, 1. And the output is there, and it's also stored in the memory. From OR operation, let us do an XOR operation, which is 0, 1, 0. So we'll change it to 0, 1, 0. There it is, and there's the output. And it's stored in the memory. Let us do a NOR operation, which is 0, 1, 1. Output changes for the NOR operation. And we can also store it in the memory, the output. From the NOR, let us do a NAND operation, which is 1, 0, 0. Same thing, output changes for the NAND operation, and also we can store it in the memory. From there, let us do some arithmetic operation. Let us begin with addition. So according to our table, addition is 101 in the operation selector, and the B inverse has to be 0. So if we add 15 and 13, the result should be 28, and that is what comes up in the output in binary, and we can also store that. That is stored. Let us do subtraction. So for subtraction, operation selector stays same 101. But B inverse is now 1. As you can see, the output is 1, 0, which is 2 in binary. So if we, and also we could store into the memory. So now we're going to do our last operation, which is set less than. So what set less than does is that if A is less than B, the output will be 1, or it will be 0 otherwise. So if it is 1, 1, 0 in our table, and B inverse has to be 1, as you can see, the output is 0, meaning that A is not less than B. So if we go back, A is 15 and B is 13, which is true. Let us do one more thing. So if we increase the bit of B, you can see that the output is now 1, meaning that A is less than B. So this was pretty much it for our presentation. Thank you, everyone.